Okay, this is a calculus class, and we're going to eventually take derivatives of vector functions, but derivatives are defined in terms of limits. So we need to talk about limits of vector functions. These are really not so bad, other than the fact that limits themselves are actually a little bit of work at times. But other than that, in terms of actual cognitive load, there's not too much going on here. Okay, it's just going to be component wise. Here's the definition. If r of t is the vector function f of t, comma g of t, comma h of t, so you have these three formulas in T, and these are scalar functions. I mean, these are like regular functions, so that's why there's no arrow on the f, g, or h. Then the limit of r of t as t approaches a is the limit of f of t as t approaches a, comma, the limit of g of t as t approaches a, and the limit of h of t as t approaches a. So it's just one component at a time. It looks like the limit distributes. I don't know that I'd really want to use the language distributes because there's no plus signs, but it's not meant to be too bad here. So let's just look at this example. We've got the vector function r of t equals t squared sine of 1 over t, comma, t to the eighth plus 1, comma, root t plus 4. Let's find the limit of this vector function as t approaches 0. So I rewrote the final, the expression that's at the end of the question, and I just, in the next step, copied the limit notation and then replaced the r of t with its definition that's in the angle brackets, and it's written right here. Then, just according to the definition of a limit of a vector function, the limit of a vector function is just taking the limit of each of the individual components. So it looks like this, right? Again, it looks like the limit distributes, even if I'm a little shy to use that language. And then the point is that the limit of this first, this is a Calc 1 question here, limit as t approaches 0. I know in Calc 1 it would probably been an x, but now it's a t. Limit t approaches 0 of t squared times sine of 1 over t. That's a Calc 1. It's a challenging Calc 1 problem, don't get me wrong, but that limit is going to be 0. And then limit of this polynomial t to the eighth plus 1 for a polynomial, a continuous function. It's what the Stewart calculus book calls the direct substitution property. You get 0 to the eighth plus 1. And then this radical function, it is continuous at the root t plus 4 is continuous at t equals 0. So due to continuity, we can just substitute in here and get root 0 plus 4. So in the end, you get the vector 0, 1, 2. So actually, one thing maybe we should say here, actually for this first one, the most confusing one, how is the limit t approaches 0 of t squared times sine of 1 over t going to equal 0? I would just ask you maybe to draw the graph in Desmos or something, but it's a squeeze theorem or sandwich theorem thing, really, but let's not go there right now. I forgot that I have this comment here. I think maybe the key thing to note is that the limit of a vector function ends up being a vector.